Have you ever questioned the fabric of our existence, the intricacies of space and time? These two elements, woven into the very foundation of our universe, have sparked curiosity, fascination, and countless debates amongst scholars and thinkers for centuries. Space and time, once considered separate entities, have been the subjects of philosophical and scientific exploration from the days of ancient Greece. The philosopher Aristotle, for instance, believed that space was a container that could be filled with objects, while time was a measure of change. Fast forward to the 17th century, and we find Sir Isaac Newton, who painted a picture of space as an infinite, unchanging stage upon which events unfold. Time, according to Newton, flowed at a steady, unalterable pace, unaffected by the motions of the celestial bodies. Yet, as our understanding of the universe deepened, so too did our perception of space and time. Enter the 20th century, and a certain patent clerk named Albert Einstein, who would forever alter the way we perceive these fundamental concepts. Einstein's theory of relativity, a groundbreaking piece of scientific thought, proposed that space and time are not separate, but interwoven into a single entity known as space-time. This theory, which at first seemed counterintuitive, even absurd, challenged the very foundations of physics, shaking our understanding of the universe to its core. But Einstein didn't stop there. He further proposed that the presence of mass and energy could curve this fabric of space-time, a concept that brought a whole new dimension to our understanding of gravity. So from Aristotle to Newton and then to Einstein, our grasp of space and time has seen a remarkable evolution. Each new insight, each revolutionary idea, has brought us closer to understanding the very fabric of our existence, the cosmic stage upon which we all play our parts. So what if we told you that time is not as constant as your wristwatch would have you believe? Albert Einstein, a name synonymous with genius, had a radically different approach to understanding the universe. A patent clerk in Switzerland, Einstein was far from the mainstream scientific community when he began to question the very foundations of our understanding of the cosmos. Einstein's theory of relativity, proposed in 1905, was a groundbreaking departure from the traditional Newtonian physics that had held sway for centuries. Newton's laws, while effective for most everyday phenomena, fell short when dealing with the high speeds and vast distances of the cosmos. Einstein dared to imagine a new framework for physics, one where the laws remained consistent for all observers, no matter their speed or direction. Imagine you're on a train, whizzing past the countryside. To you, inside the train, a tossed ball would move normally, but to someone outside, the ball would appear to curve as the train's motion adds to its own. According to Newton, these are two different realities, but Einstein proposed a radical idea. Both are true, depending on the observer's perspective. This principle, known as relativity, shook the very pillars of physics. Einstein suggested that there wasn't a fixed stage upon which the drama of the universe played out. Instead, he proposed that the stage itself was in constant motion, changing based on the actor's movements. Einstein's theory also had profound implications for our understanding of light. It stated that the speed of light is a constant 300,000 kilometers per second for all observers. This was a revolutionary idea, challenging the then common belief that light would travel faster if you ran towards it, just like a train would seem to approach faster if you moved towards it. Einstein's theory, in essence, suggested that space and time were intertwined into a four-dimensional fabric known as space-time. This was a revolutionary leap in our understanding of the universe, one that would forever change how we perceive the cosmos. It was a bold step towards a new era of physics, one where the universe was far stranger and more fascinating than anyone had ever imagined. Imagine the universe as a giant sheet of fabric. This is the concept of space-time. Picture it as a two-dimensional plane, stretched out infinitely in all directions. Now what happens when you place a massive object on this fabric? Just like a bowling ball placed on a trampoline, it causes a dent or distortion in the fabric. This is the essence of Einstein's revolutionary concept of space-time. When we talk about space-time, we are referring to the four-dimensional structure of the universe, combining the three dimensions of space that we are familiar with, length, width, and height, with the fourth dimension of time. Together, they form the very fabric of our universe. So, How do massive objects fit into this? Well, the more massive an object is, the more it distorts or warps the space-time around it. This warping creates a kind of slope, which smaller objects then slide down. Imagine rolling a marble towards the bowling ball on our trampoline. The marble would naturally roll towards the bowling ball, not because of some invisible force pulling it, but simply because the fabric of the trampoline is curved. In the universe, this is exactly what happens. Planets orbit stars, and moons orbit planets, not because they are being pulled by some mysterious force, but because they are moving along the curves created by these massive objects in the fabric of space-time. This is what we perceive as gravity. The idea of gravity as a curvature of space-time was a radical departure from the previous Newtonian view, where gravity was considered a force that objects exerted on one another across space. Einstein's theory, instead, presented gravity as a natural consequence of the geometry of the universe itself. In this way, Einstein gave us a new understanding of gravity, not as a force, but as a curvature of space-time. It's a concept that continues to shape our understanding of the cosmos, guiding our explorations into the vast mysteries of the universe. Ever fantasized about time travel? Einstein's theory of relativity makes it seem less like science fiction. Welcome to the fascinating world of time dilation, a mind-bending consequence of Einstein's theory of relativity. This concept suggests that time isn't as straightforward as it seems. It can slow down or speed up depending on how fast you move relative to something else. It's like a cosmic speedometer, where the needle of time ticks slower the faster you go. Let's dive deeper into this concept. Imagine you're on a spaceship traveling close to the speed of light. According to Einstein's theory, if you were to look at your watch, you would see the seconds ticking by normally. However, if someone on Earth were to look at your watch, they would see the seconds ticking by much slower. This is time dilation. Your time is literally dilating or stretching out compared to the time on Earth. Now, you might be thinking, this is all theoretical, right? It doesn't happen in real life. Well, not quite. Time dilation isn't just a thought experiment or a plot device for sci-fi movies. It has real-life implications, and we have to deal with it in our everyday technology. Take the Global Positioning System, or GPS, for instance. The satellites that provide GPS signals are moving at high speeds and are farther from the gravitational pull of the Earth compared to us. Due to time dilation, the clocks on these satellites tick slightly faster than the clocks on Earth. This difference might seem negligible, but even a fraction of a second off could result in significant errors in positioning data. Hence, to ensure accurate GPS data, the system has to constantly correct for the time dilation effect. This brings us to a fun fact. Astronauts, while living and working in space, experience time dilation. Despite the minuscule effect, they age slightly slower than the rest of us on Earth due to their high-speed journey around our planet. So, in a sense, astronauts really are time travelers, aging slightly slower than the rest of us on Earth. Einstein's theory of relativity has far-reaching implications, influencing various fields of study and technology. Imagine a world without GPS. It sounds like a nightmare, doesn't it? But did you know that Einstein's theory of relativity plays a crucial role in the functionality of GPS technology? The satellites that provide us with GPS signals are moving at high speeds and are far from Earth's surface, which according to Einstein affects the passage of time. Thus, to ensure accurate location data, the GPS system must account for these relativistic effects. Without Einstein's theory, your GPS would be off by several kilometers within just one day. But that's just one example. The theory of relativity has also reshaped our understanding of the cosmos. It has led to the prediction and discovery of black holes, regions of space where gravity is so strong that nothing, not even light, can escape. It has given us the concept of a dynamic, expanding universe and has set the stage for the search for dark matter and dark energy, elusive components that make up the vast majority of our universe. Moreover, Einstein's theory has opened up the tantalizing possibility of wormholes. These are theoretical passages through space-time that could potentially allow for faster-than-light travel or even time travel. While still purely speculative and riddled with scientific challenges, The very idea that they could exist is a testament to the revolutionary impact of Einstein's work. It's clear that the influence of Einstein's theory of relativity extends far beyond the realm of theoretical physics. It has practical applications that affect our daily lives, and it continues to inspire new avenues of scientific exploration. From the technology in our pockets to the mysteries of the cosmos, the echoes of Einstein's revolutionary ideas can be heard. So next time you glance at the time on your phone's GPS, remember you're experiencing a little bit of Einstein's revolutionary theory in action.